Today we are starting our session of CCNA, that is Cisco Certified Network Associate, and exam number is 200-125. So before we are starting CCNA, first we will just go through a basic networking. So what is computer network? So computer network is made up of a set of computers connected by a communication line. This communication line is also known as a communication medium, and the purpose is to share resources. These resources are like internet, printer, and file server. So here we have taken one simple home network. You can see that it's a wireless router is there, laptop, desktop and tablet is there, and they all are sharing internet. Next is a basic type of network. So the main basic type of network are local area network and wide area network, as well as the other type of network are MAN, metropolitan area network, PAN, personal area network, and SAN, storage area network. LAN is limited to a particular geographical area, that is 1 kilometer, or is associated with a particular organization. Here there is no third party involvement. The different characteristics of LAN are it provides high data rate because it is in a limited geographical area, as well as it is less expensive technology because here we are using layer 1 device, that is hub, and layer 2 device, that is switch. And the different type of technology used over here is Ethernet and token ring. The other type of network is wide area network. A wide area network is not restricted to a particular geographical area, and maybe it is interconnected to a different type of LAN and MAN. Generally it is more expensive technology because here we are using layer 3 device, that is router, and a more advanced technology. It is basically exist in unlimited geographical area, and the technology used over here is MPLS, frame relay, ATM, and X.25. So next we will discuss about a network architecture. So there are two basic network architectures are there. First one is a peer-to-peer and the other one is a client server. So first we will discuss about peer-to-peer architecture. So peer-to-peer architecture is distributed architecture. In this architecture, each and every task are allocated among all members of the network. There is no hierarchy like client-server architecture, and there is no central computer like a client-server architecture. Mostly used in file sharing purpose. Next thing is client-server architecture. A number of computer or client, you can say that it's or a workstation, are connected to a central server. Client is basically request to server, and server is provide response to a client, and it also provides services to client, we can say that also. So there are different type of server. Here we are using is email server, print server, and storage server. So next we will discuss about LAN transmission method, that is local area network transmission method. So there are three methods. First one is unicast. In unicasting, there is one sender and one receiver. The message sent by one sender is received by one receiver. Next thing is multicasting transmission. So in multicast transmission, sender is always one, but A receiver is a group of member. So a member of group is receive this message. The next thing is broadcasting. That is one to all. So one sender is sending any message, it is received by all member of local area network. That is known as an broadcasting. So next thing we will discuss about topology. Topology, the basic topologies are there like bus topology, ring topology, star topology, tree topology, mesh topologies, many topologies are there. So one by one we will discuss this topology. First one is bus topology. So all the nodes are connected to a single backbone. So here backbone is very important. Single broadcast and all the traffic are traveled through this backbone. And all nodes are connected by T connector to a backbone. So here terminators are also used at the end of backbone. But the basic drawback of this bus topology is when backbone will go down, entire network will go down. So that's why bus topology is used in a small network. It is never used in large network. So next topology is a ring topology. So in ring topology, each and every node are connected to exactly two nodes. So here I had considered one scenario, that is PC1, PC2, PC3 and PC4. All four computers are connected in ring. So if the message is generated by PC1, it is transferred for PC3. So PC1 is sending that message. It is first received by PC2, then it will receive by PC3. So PC2 will check that message, that message is for me. So if it is not for PC2, then it will just forward that message to next node. By this, it is a single continuous pathway for signals through each node. Here for backup, they are also using a dual ring, because if one link will go down, the entire network will go down. So that's why here they are also using dual ring. So if one ring will go down, the another ring will come up at that time. So next topology is star topology. In star topology, that is a central hub or switch we are using. So all the nodes are connected through that hub or switch. So here the benefit is that if single link or node will go down, the entire network will never go down. And another thing is that we can extend this topology, as you can see over here that I had extended that topology. In the center I had used switch and then I had used hub, and it is known as an extended star topology. The next thing is a mesh topology. The mesh topology gives you 100% backup, because all nodes are connected to other nodes with a dedicated connection. So if one communication line go down, we always get that backup. Like an example, if this PC is connected to this PC by this direct line, okay, but if it will go down, this line will go down, the data will go through this. It has the alternative path like this one as well as this one, or the third path is this, from here to here, from here and here. So here the mesh topology will give you 100% recovery. So next thing is TCP IP model. There are two models are there, that is TCP IP and OSI model. So TCP IP model is invented in 1960 by Department of Defense America. In TCP IP model there are 4 basic layers. The last layer is network access layer, then internet layer, transport layer and application layer. So in network access layer we are using a different type of technology like Ethernet, token ring, frame relay and ATM. Internet layer is same like a network layer in OSI model, and the protocol over here is IP security, ARP that is address resolution protocol. The next layer is a transport layer. In transport layer we are using 2 type of protocol, that is TCP and UDP. TCP is a reliable protocol where UDP is unreliable protocol, because TCP provide you connection oriented services where UDP provide you connection less services. Now how it is reliable and unreliable? So if we are talking about TCP, it is reliable because it provides acknowledgement as well as flow control by concept of windowing. But in UDP there is no acknowledgement is given by receiver. So that's why UDP is unreliable protocol. Where now we will discuss about application layer. So application layer is basically behaves like an interface between user and machine. So it directly interact with the machine, and by using a different type of protocols like Telnet, FTP file transfer protocol, simple mail transfer protocol, SMTP, DNS, SNMP and HTTP. This model is a practical model, and next model is OSI model, that is theoretical model. OSI model is made up by ISO. In OSI model there are 7 layers. The last layer is a physical layer, then data link layer, network layer, transport layer, session layer, presentation layer and application layer. So physical layer is the lowest level. In that layer the data is in a form of bit. In the data link layer the data is in form of frame. So in frame it also maintains sequence of frame, as well as it is also responsible for error checking. It just add header and footer and the data so that it can check that error by checksum, as well as it is also responsible for media access control. Next layer is a network layer. So network layer is also responsible for routing, and in this layer data is in a form of packet. It also subnet a network, that is a subnetworking, and by that it control traffic. Next layer is transport layer. In transport layer data is in a form of segment. In this layer the traffic control is also handled by transport layer, as well as the session, that is the upper layer sessions multiplexing is also done over here. The session layer is responsible for dialog control. It establishes sessions, maintenance of that session, termination of that session, as well as it is responsible for session security and logging. Next layer is a presentation layer. This presentation layer is associated with syntax and semantic. It is also responsible for character code transmission as well as data conversion. Here, it is also responsible for compression and encryption. Next layer is application layer. The application layer, as we had discussed in TCP/IP, it is also responsible for remote file access, network management, email, and the other thing like SMTP protocols are also used over here. So here, whenever senders send any data, the application layer, it just gives that data to presentation layer. So up to session layer, application layer, presentation and session layer, the data is in a form of protocol data unit. That is a normal data. But when session layer transfer that data to transport layer, that transport layer divides that data into a segments and gives that segment a number. Whenever and always there is header is added at the beginning of that data. So in each layer, when it comes to network layer, then the packet, that is IP address, that is sender IP address and receiver IP address, is added over there. And in data link layer, the particular packet is divided into a frame. And in the last layer, finally it divides into a bits like 1 and 0 in a binary form. And by communication line, that data in a bit format travel through a communication line, it reach up to a receiver. So this is all about OSI model. So now we will compare TCP/IP model and OSI model. So TCP/IP model basically used widely. It is client server model and it is used to transfer data on internet, where OSI model is a theoretical model, as I said, which is used for computing system. In TCP/IP model there are 4 layers, where in OSI model there are 7 layers. It is developed by Department of Defense, where OSI model is developed by ISO, that is International Standard Organization. TCP/IP model follow vertical approach, where OSI model follow horizontal approach. TCP/IP model is tangible, where OSI model is not tangible. Now